So you asked me about this problem. There is this function h to the n that basically is the multiplication of all the even numbers up to n. And then they're asking you what is the smallest prime factor of h to 100 plus 1. So basically h to the 100 plus 1 it will be all the multiplication up to 100, and then to that you add 1. And the possible answers are the prime factors between 2 and 10, or a prime factor between 2 and 10, or between 11, 10, 21, 30, 30, 40, or bigger than 40. So first thing we can see very clearly, all these numbers are all even. So basically you take the common factor 2, and what is left is 1, 2, 3, 4, 50, or 1, 2, 3 up to 50, which is 50 factorial. You compute this and you add 1. The problem is, what is the prime factor of all that? The smallest prime factor. So you can see this might be a big number. This will be a big number. It will be even. So this number will be odd. But it's such a big number that you have no clue what the smallest prime factor is going to be. You have no idea if it's going to be divisible or not by anything, because this can be like 3,221,000, and then if it's prime or not. So first thing we know for sure is that you will never know the value of this. And the second thing that you know is time is more relevant than getting this right. So if you're in the exam, top priority, keep your time under control. So now probably for other people that have already tried this, you can probably try, think a little bit about it, stop the video. And then if you don't, probably let's see how we solve this. So the one thing we know is that either you know how to do this or you don't. So if you don't, in the exam, probably move on, because you will spend a lot of time otherwise. So how do we actually do this? Well, the concept of coprimes or consecutive, the relationship between sharing a prime factor and consecutive numbers is very clear in this box. Consecutive numbers don't share prime factors. So quick examples, 9 and 10, for example. 9 is 3, 3, 10 is 2, 5. Or 56 and 57, it's 7 and 2 to the cube, or 3 to 19. So they don't share any prime factor. Basically, you can do this for any number and they will never share a prime factor, because the difference between the two numbers is only 1. So they will not have share a prime factor like 2, 3, 5, or any other number. So now we can use that to solve this, because we know that these two numbers are consecutive. This part of the number, basically 2 to 50, and the next number, which is 250 multiplied by 50 plus 1. So this is the consecutive number after this. And we don't know anything about this, but we definitely know something about this. This number has all the prime factors up to 50, because it's 2, 1, 2, 3, 4, 5, 6, 7. It's divisible by all the numbers up to 50, because it's a factorial. So this number will be divisible by anything that you want, but not any number up to 50. So it will have some prime factors after 50. And you don't even need to worry about which prime factor it will have, because you know that it's going to be bigger than 50. And the options were between 10, 20, 30, 40, or bigger than 40. So that's the right answer, bigger than 40. I think this is pretty high level in the exam. So either you know it or you know. So the big takeaway is either you know it or you don't. So if you don't, you probably want to move on, because you're not going to get it right. Either if you don't know this, you're not going to get it right. So you don't want to waste your time in the exam.